Hello everyone. So in this video, what we will demonstrate is how we can provide a public IP address to a spoke, which is connected behind a Starlink connection. And once the complete setup is done, how a services which is hosted behind the spoke can be reached from the internet, right? So the main issue with the spoke which are connected behind the CGNAT IP behind the Starlink is they receive a CGNAT IP address, and this IP address is not publicly routable, which means that anybody sitting on the internet cannot reach this public IP address. So now the challenge arises. Let's say if you want to host any service which is behind the NSE 3000. For example, let's say you want to host a web server and provide reachability to the users, then it is not possible unless and until you have a public IP address on the NSE, which could be reached from the internet. So what we did is we built a hub and spoke WireGuard architecture by which NSE 3000 will form a WireGuard tunnel to the hub, which is there on the wire and which has a public IP address. And once this WireGuard tunnel is formed, we create a virtual WAN interface to which we provide a public IP address. And the traffic to this public IP address gets routed over this WireGuard tunnel, right? And then what we will do is we will create a port forward so that any traffic reaching to this public IP address then can be forwarded to the host sitting behind the NSE, right? Once that port forward is configured, any user who is there on the internet should be able to reach. They should be able to do a remote desktop or HTTPS and fetch a page or gain access to the device, right? So we will build the configuration both on the hub side and the spoke side, and I will show you the steps how we can do it, right? So let's get started. I already have two NSEs. This is the hub NSE, which is on a public IP address. And this is the spoke NSE, which is on a Starlink connection, right? Because it is having a CGNAT IP address, right? So we'll start off with the hub configuration. Let me add a, so let me just sync the configuration first. Right. So I will go to the VPN and make sure that the WireGuard server is enabled. Configure a DHCP pool. Basically, this is a pool from where the WireGuard client will be assigned an IP address. So we add a new user, just give it any name, test public IP @email.com. Then you can select the WAN interface and add a client for this user. So I can say NSE 3000 WG spoke. I download this configuration, click add, save this configuration. Now the next step is we will use this generated configuration from the server and build our spoke configuration. So we go to the spoke NSE, click edit, go to the WAN page, click on add virtual interface. First we will do this WireGuard client configuration from the generated config. So as you see here, we will grab this WireGuard server IP address. Server port is 51820. Assign the local IP address. Copy the private key. Copy the public key. Then we will assign the public IP address to this interface. So the public IP address is of the same subnet. The last octet changed to 5. We will also provide the local subnet whose traffic needs to be forwarded over the tunnel. So that will be 192.168.200.0/24. Click save. So that completes our client configuration. Now to provide that connectivity to this public IP address, we have to do some additional configurations on the hub. Basically, we'll have to add a DNAT rule saying that any traffic which comes to this public IP address, DNAT it and forward it to over the WireGuard. Similarly, any traffic from this LAN which is received on the hub, then should get source natted and then forwarded, right? So I will just show you that source, the configuration. Here, basically on the hub, we'll have to enable the proxy R and then configure the source NAT rule and this DNAT rule, and then allow this as for the WireGuard user, right? We will copy this whole configuration and then we will apply it on the hub using the overrides. So this is the spoke. I'll save this config. All right. So this completes our hub side configuration. On the spoke, we should see the status of the WireGuard interface or the virtual WAN interface should be up. So we'll execute, in order to check that, we will say check this. So virtual WAN status. So this interface should come online. Let's just refresh that. Yeah, so we can see that the virtual WAN interface is up. We should also see the virtual WAN interface using the CLI should also indicate that it is up. So as you can see here, we see the received and sent bytes, which are incrementing. So that indicates that the tunnel is up. Now the next configuration that is required on the spoke is we need the port forward here on the spoke so that any IP address reaching here, any traffic reaching on this public IP address should be forwarded to the client which is connected on the LAN. So we have a couple of clients connected on the LAN. So we will port forward to this IP. So we'll add a NAT one-to-one rule. Select the virtual WAN interface. Configure the public IP address, which is this. Change to 165.192.168.200.51. We'll save this config. All right. So now we should be from our let's say I am a user sitting on the internet. First of all, I should have reachability to this public IP address. Now, if I do a remote desktop, I should be able to reach to the host which is sitting behind the NSE, right? So let's initiate a remote desktop connection. So this is the public IP address 62.252.177.165 on spoke NSE. Yeah, I am able to establish the remote desktop connection to the remote host, right? So as you can see here, this is the IP address of the remote host behind the NSE, right? So this building it is that simple, and we can easily provide connectivity to the host behind. Even though if the connection is over CGNAT, we can still provide an IP address and provide connectivity to the remote host from the internet, right? And this is extremely secure because this is an encrypted channel over which the traffic is routed. Simple to build the configuration, and it is very scalable using NSE 3000. So that completes our demo, and thank you for watching.